Hello, Algebra 1, we're in 8.6. So there's one paper that if we were together, we would have filled in day by day and eventually had a quiz. So if you can find that from the packet, it'll say Chapter 8 vocabulary. We'll just sort of fill that in day by day with each other. And I'll decide later someday if we're going to do that as a quiz or just as an information gathering source. Well, number 1 on that sheet says, what is a rational expression? So if you don't have that paper yet, go find it and come back in a minute and pause the video. But a rational expression is a fraction with a polynomial, which lends itself to question number 2. What is a polynomial? That's the sum or the difference of monomials, which lends itself to what's a monomial, which is a monomial can be a real number or a variable or a product of those, meaning you could multiply those. A mixed expression we talked about in the most recent video last time in 8.6.1. A mixed expression is just the sum or difference of a polynomial and a rational expression. So if you have a rational expression adding or subtracting a polynomial, that is a mixed expression. Today we have complex rational expressions, and we're into the 8.6 notes, 8.6 part 2. You should have notes for that in the packet. A complex rational expression you can see behind me on my right and left. I'll start in this column on your right in a minute. A complex rational expression is a fraction in another fraction. So you can see we've got a main fraction with a big long fraction bar, and then on its top there's fraction, on the bottom there's more fractions, there's fractions inside of other fractions. So the other note that's worth writing down today, how we simplify these, is that we are going to multiply every fraction by the LCD to cancel the bottoms. And by LCD I mean least common denominator. So we're going to multiply each fraction by an LCD to cancel all the bottoms. And I'll just drop these papers off because I don't need them anymore. So your first move on any of these is look at just all the individualized bottoms. So I'm looking at the x, the y, the 2x, and the 2y. I'm not looking at any tops to begin these problems. I'm only going to look at all the individualized bottoms, and this has 4 of them. X, y, 2x, 2y. I look at those 4 items in this case. This I only have 2 to look at, this bottom and this bottom. But I'm going to look at all of the bottoms, and I'm going to pick out a common denominator. The word of the day on common denominator day was most. We pick everything the most we can ever find it in one location. So since I see some 2's, I need to take a 2. If this were a 2 and a 3, I would take a 6, because 2 and 3 go into 6. Or if this were 2 and 8, I would just take the 8, because 2 goes into 8. We're just picking an LCM like we have on a lot of other circumstances. I also need to take an x because I see one here, I see one there. The most I ever saw was one of them. If this had a power on it, I'd have to take that power as well. But nothing had powers, so I'm good with just an x. I'm also good with just a y, because all I see here are y's. 1 at a time is the most, so that is my common denominator. For whatever reason, I always pick my common denominator and I just sort of circle it in this area of the problem, just so it's easy for me to see and look at and communicate about later. I'm just going to make a little circle area where the LCD is going to live. So then the goal of this in life is to cancel the bottoms. We're going to multiply each of these 4 areas by that common denominator, with our job being to cancel the bottoms. So for right now, I am only worried about the one area you can see. If I multiply the circled LCD by that fraction, the x's would cancel. This x is on the bottom, this x would be canceled, 2 and y would still sit there, multiply the top, and I just created myself a 2y. I'm going to end up having to fill these 4 areas. So then I would tack this zone. In this zone, the y's would cancel, because this is invisibly like it's over 1, if that helps you. Okay, so this y is the bottom, this y is the top, those y's would cancel. 2x wants to multiply 1, and it's nice when you multiply 1 because you just get 2x back. Then I would tackle a different corner. In this corner we can see the 2's and x's would cancel. The y would be left from the circle stuff. Y times 1 is y. And when we tackle this final corner, the 2 and the y would both cancel. Only the x would be left from the circled stuff. The x would multiply 1 and we'd get x. By the way of how we chose it, this always has to happen that way. The way we chose this is in such a way that all of these bottoms are going to be canceled by it. Likely that there will be some more pieces left in this, and those extra leftovers multiply the tops. Sometimes you get this far and you're done, but always what we should think about is whether we can factor anything, because that can open a door to being able to cancel. On this top, we can factor off a 2, that's a GCF. So this is out, this is in. The bottom invisibly is in parentheses. That's a perfect match. We didn't cross out the 2. My best final answer on something like that is a 2. Bad news is, these are a little bit lengthy because you have to attack like 4 different areas. The good news is they're all basically the same process. So if you think you understood that process, great, you're going to be good. If you don't understand it yet, we'll work our way through 4 more, and hopefully you have a feel by the time that we're done. And if you don't, send me an email, we'll work something out by video conference or some other way, some other time. For this, I need to look at all the bottoms again, and there's 3 of them that I can see. I'm not worried about this, because that doesn't have a fraction in its area. Okay, but these 3 bottoms, I have to look at those. All I see is m's, and the word of the day for filling this circle is most. The most I see is an m squared. So I'm going to go over here and create a new area. Let me do this first, because there's no cancellation for this, because there's no fraction. So 1 times this is m squared itself. Let me do this matchup next, just because I can see it's a perfect cancel of m squared. It's completely gone. And I just need to bring the top along for a 2n. This top left does the same thing. Perfect cancel of m squareds with nothing left, except for a 2n. This one there's a cancel with some leftovers. When this circle, LCD, cancels the bottom, we're still left with an extra m. That extra m should multiply the top, and there we have an m. I would think for a minute if I could factor anything, but I can't. And if I can't factor, I can't cancel, so I'm done. For this one, I'm only looking at 2 spots. I'm looking at these 2 bottoms. I only see x's. The most I see is an x squared. So now I'm going to take this x squared and it's going to multiply all 4 of these zones. Top left, top right. Bottom left, bottom right. Its job is to cancel these fractions, but everything is going to change. So x squared times 1 is nice. On the bottom, x squared times 1 is also nice. On the bottom right, you get a perfect cancel of x squareds to only leave that 9. On top, you get a slightly imperfect cancel. The x and the x squared would still leave one of these x's to multiply the top. This is always trying to multiply the tops. It's always trying to cancel the bottoms. So this extra x from the cancel multiplies the top, and we get 3x. Sometimes we're done. Sometimes we have factoring to do. This has factoring to do. The top we could take out a GCF of x to leave x plus 3. The bottom is a difference of squares, x plus 3 and x minus 3. Perfect match of factors. So best answer for that is an x on top and x minus 3 on the bottom. If you still want to write those parentheses, you can. You can also choose to make them invisible. Totally up to you. Stroll to the left here to my other column. So on this, the bottom has those kind of invisible parentheses that I just referenced. At first, I don't even look to these, because there's no fractions there, and I'm looking for bottoms to start the problem. The only thing on the bottom is x plus 3. I don't need any powers because these didn't have powers. The only way we have powers in the circle LCM is if the problem had powers on the bottom. So, it doesn't matter what order we tackle these in. So let me do the cancel ones first. X plus 3 is a perfect cancel for this x plus 3. And all that's left standing after the minus is our 10. Likewise, this has a perfect cancel of x plus 3's, where all we're left with is the 4. In the 5's world, we don't have anything to cancel because it wasn't even a fraction. So 5 just wants to multiply x plus 3. And likewise 2. There's no canceling because 2 is not a fraction. We just want 2 to multiply the x plus 3. And then we need to go into a little bit of cleanup mode to try to combine like terms and do what we can to make this smaller. If we distribute here, it's 2x plus 6. So on the bottom, 2x plus 6 subtracts 4. That's 2x plus 2. On top, distributing would get 5x plus 15. 5x plus 15 minus 10 would be 5x plus 5. And frequently at that point you're done. But you should always try to think if you can factor. Here you can take out a 5 on top to replace that. You can take out a 2 on the bottom to replace that. We do get a perfect match, so my best answer on that would just be 5 over 2. And we'll do one more. For this, I'm not looking at these at all at first. I'm looking at only the bottoms as always. Common denominator choice would be the x plus 2. The part after the minus here has a perfect cancel to just leave a 3. The part here on the bottom has the same exact thing. Perfect cancel, same 3. Top left, the x would want to distribute x plus 2, because there was no cancel. On the bottom where the 1 was, 1 times anything is just that anything, same thing, right back to us. A little bit of cleanup. On the bottom we have like terms. Add 2, subtract 3 would make us subtract 1. A distribute here would make x squared plus 2x, but there's no like terms there for x squared plus 2x minus 3. Yeah. Small mistake there. Caught it. Then we should always think about factoring before we call it quits. The top does factor x and x. With a minus, we do different signs. Plus hogs the bigger number, which is 3 compared to 1, because that multiplies to 3, subtracts to 2. That's out. The factors are in. Those invisible parentheses are there on the bottom. That lets us cancel. And the answer on that is going to be x plus 3. So homework on this. We're on the same page we were on yesterday, 339, but we're just filling in the missing gaps. Yesterday you did 1 to 12, skipped a few. Those are the ones we're doing today. There's a 13 to 24, and then also trying number 36 with these sort of skills. Email me if you have questions.